Okay, open your books. Right. Sorry. Come again. Yeah, because it's cold. Because it's cold. Okay. All right. Fine. Okay. Let's carry on. Let's carry on. All right. Let's look at exercise 35, stoichiometry. Right, the homework that I gave you yesterday, you're gonna go over this, check what's happening here. So let's start. 1.1. We start. The first step in the extraction of zinc from zinc sulfide, right? ZNS is the combustion of zinc S in oxygen. The balance equation for the reaction is given as 2 zinc sulfide solid plus 3 oxygen gas to give you zinc oxide solid plus 2 SO2, that is sulfur dioxide, right? To give you 2 sulfur dioxide plus energy, clear? Right, the energy there, because energy is a product, it makes this reaction to be, to go what? Endothermic or exothermic? Huh? What's an endothermic reaction? We haven't done that, but you have an idea of what is an endothermic reaction.
Energy is needed to make the reaction take place.
Right, so endo means, endo, I think in life sciences you do endoskeleton and exoskeleton. Endo means outside, exo means inside. Sorry, is it exo? It's out, ne? Endo it's in. Right, so endo means in. Thermal means heat. So endothermic reaction, it means it's a heat must be added into the reaction for it to take place. Exothermic, it means heat will be given off during a reaction. Right, so here energy is a product. So it means this reaction becomes an exothermic reaction because energy is a product. So it means it's being produced. Clear? All right. Oxygen gas consists of oxygen molecules. 1.1.1, define the term molecule. Define the term molecule for 2 marks. What do you say? What's the answer? What is a molecule? What's a molecule? Yes, Paul. Right, two or more atoms that are held by chemical bonds. Which chemical bond? Remember, we did different chemical bonds. We looked at covalent bond, we looked at the ionic bond, we looked at metallic bond. Which bond is a molecule? Ionic. Right, it's a covalent bond. So it is a molecule. It's a molecule is where a group of 2 or more atoms, right, are covalently bonded. They are covalently bonded. Why do we specify covalent bonding? Because you get a molecule for substances that are non-metals, where they share electrons. In an ionic bond, what happens? Electrons are transferred from a metal to a non-metal. Is that clear? Right. So define the term molecule. Molecule, you're supposed to define it like this. It's a group of 2 or more atoms that are covalently bonded. Right, so you use that part there. All right, we're talking about this. All right, so we're talking about this. stop here. Right, a group of two or more atoms that are covalently bonded. All right, that's what we have. We move on to the next one. Draw the Lewis dot diagram of the oxygen molecules. Draw the dot diagram of the oxygen molecule. Right, so for the Lewis diagram, just to remind one another what we've done initially. Oxygen, you look at oxygen, what group is oxygen? 6 or 16. Right, so we've got how many valence electrons? 6 is 1, 2, 3, 4, 5, 6. Then the other oxygen again. All right, we also have 1, 2, 3, 4, 5. These are just dots that I'm making here. Right, 6. So put another one. All right, so what is going to happen here? When they bond, this one is going to bond with that, and this one is going to pair with that one. So this will pair up. Right, to form a molecule like this. All right, so this is your final answer here. That's the oxygen. All right, so the molecules, the bonding electrons, this one becomes your bonding electrons. These are your bonding electrons. The other ones become your lone pairs. They are not involved in bonding. So that's what we have there. Right? Right, for 2 marks, the definition for molecule there, the keywords are 2 or more atoms. And the other keyword there is covalently bonded. So just bonding, you're not going to get full marks here. You get 1 out of 2. You have to include covalently bonded. In 2 marks here, showing the bonding electrons as well as the lone pairs there correctly, you get 2 marks. Right, move on to the next one. Next one. The next question says, during the reaction above, 7 grams of zinc sulfide reacts completely with oxygen. So zinc sulfide reacts completely with oxygen gas. All right. Then the question says, calculate the number of moles of zinc sulfide that is reacted. Number of moles. All right. Number of moles. We need number of moles. How many formulas do we have for calculating number of moles? 4. The first one, number of moles is equal to mass over molar mass. That's number 1. Number 2, we have got number of moles is equal to number of particles over Avogadro's number. Number 3, we have number of moles is equal to concentration times volume. Number 4. All right, number 4. Number 4, we've got number of moles is equal to volume over molar volume. All right, and this is at STP. At STP, standard temperature and pressure. And at STP, your volume, molar volume becomes 22,4. And your Avogadro's number there becomes 6,022 times 10 to the power 23. Clear? Your Avogadro's number is that one 6,022 times 10 to the power 23. Right, your molar volume, Vm, is equal to 22,4. Right, 22,4 then, provided it's at STP, cubic decimeters. So those are the equations that you have, right? These ones, you apply them accordingly. All right, let's look at this one here. So we have got to calculate the number of moles of zinc sulfide. So what do we know about zinc sulfide? Zinc sulfide, we know the mass. What is the mass? 7 grams. So which equation out of the 4 are we going to use? Number 1. So we're going to use number of moles is equal to mass, mass over molar mass. Right, we substitute, that's 1.1.3. Right, the mass is 7, divided by the molar mass of zinc sulfide. What is the mass of zinc? Zinc sulfide becomes 97. I think 65 plus 32. Right, then what's your answer? 0.07 moles, 2 decimal places, or you add the 2. I think there was a 2. That number ends at 2. So you have 3 decimal places. So you can write it as 0.072 moles, or just 0.07 if you round it off to 2 decimal places. Right? And your question here is 3 marks. 3 marks means formula, 1 mark, substitution, 1 mark, the final answer, 1 mark. Those are the 3 marks. Those are the 3 marks. All right, same applies here. When we check the memo same applies. You've got your mass over molar mass, 1 mark. Your 7 divided by 97, you get a mark. And the final answer, 0.072 moles, you get another answer, another mark. All right, we move on to the next one. We're on number 1.4. 1.4. Right, it says calculate the mass of oxygen needed. Calculate the mass of oxygen needed. So we check here, there is oxygen. Right, but what do we know about oxygen? What information do we have about oxygen? Nothing. We don't know anything about oxygen except maybe the molar mass. Are we together? All right, that's all we know. So what are we gonna do? We're gonna check what is the molar mass for oxygen. Molar mass is what? O2. It's gonna be 32. 16 times 2 is 32 grams per mole. That's what we know about 1.4, 1.14. Right, what do we need? For us to calculate mass, we need molar mass, we need number of moles. So let's check, how do we get number of moles? Number of moles, we're gonna go to our balanced equation and check, do the comparison. So let's compare. What are we gonna compare? We're gonna compare with what substance that was given its value, or substance that we know something about it. We know something about zinc. It has got 7 grams, and those 7 grams for zinc, they give 0.072 moles. So we know the number of moles of zinc sulfide. So we're going to do a ratio of what is known versus what is not known that we want. It's going to be zinc sulfide is to oxygen. What is the ratio? According to this, zinc sulfide is 2, oxygen is 3. So the ratio is 2:3. All right. If this is 2:3, what about 0.072? 0.072. All right. How much here do you expect to get here? What do we do here? We multiply. So we're going to multiply 0.072. We multiply by what? By 2 or by 3? We multiply by 3. All right. Divided by 2. All right. So what's your answer here? 0.108. All right. So you cross multiply. You're going to multiply by 3. You multiply here. And upwards you divide. So your answer here becomes 0.108 moles. Yes. It's fine. So you can have 0.07. Then here you're going to get, I think, 0.14. Fine. 2 decimal places. Right. So that's what you have. Have we answered the question? We need, no, we still need mass. So now for the mass, what we're going to do, we're going to say number of moles is equal to mass over molar mass. All right, your number of moles, we now know. What is your number of moles? It's 0.108 is equal to mass M over the molar mass, which is, we now need the molar mass for oxygen, isn't it? Which is 32. Then you make mass the subject of the formula. Mass, you cross multiply, 0.108 multiply by 32. What's your answer? What's your answer? 3,456, which you can round off to 2 decimal places, 46 grams. 3,46, that's your answer, to 2 decimal places. Clear? Right. How do you mark this? It was 3 marks. It was 3 marks. So you're going to get a mark. You're going to get it back for the ratio. You're going to get a mark for the substitution. And you're going to get a mark for the answer. You're not going to get a mark for the formula because you are repeating the same formula that you awarded marks. You are not awarded marks on this one. That means there's no mark for formula here. Mass over molar mass. But you used it here. So that's why you won't get a mark, because you don't get the same mark, or you don't get a mark for the same formula that you've used previously in the same question. Right? So there's no mark for that M over molar mass. So it's going to be 1 mark for finding the ratio using mole ratio, 1 mark for substitution, 1 mark for the answer. Clear? Right. Right, so that's what you have for 1.14. Can I delete this? Right. If I check also on my memo there, that's what you get. You get number of moles of oxygen. The ratio there, 3:2. Right, 3 over 2 multiplied by zinc. So you multiply by 3 divided by 2. You get your answer 0.108. Then you use your number of moles, mass over molar mass. substitution here, and your answer 3,46. All right, so no mark for the formula, just the ratio and finding this. Clear? Right, we move on to the next one. 1.15. Right, volume of sulfur dioxide produced at STP, volume of SO2 produced at STP. So once again, you go to your formula, you check, what do I know? I know zinc. Where am I going? I'm going to sulfur dioxide. What is the ratio between the two? The ratio is 1:1 or 2:2, isn't it? All right, so I start with my ratio. I'm going to say zinc sulfide. I've got zinc sulfide. Zinc sulfide is to SO2. What is my ratio? 1:1. But according to this equation, it's 2:2. I know 2:2. When I simplify by dividing by the common factor, it's 1:1. So the number of moles for zinc sulfide, I know them. They are 0,072 or 0,07 if you round it off. Then it means here I also have 0,072. The ratio is 1:1. Right after that, I go to volume. Volume, I'm told it's at STP. Yes, at STP. STP, I know. My volume is going to be 22,4. So I use my formula, number of moles is equal to V over Vm. Number of moles is going to be 0,072 is equal to my volume, V over molar volume, which is 22,4. Then I cross multiply. When I cross multiply, what answer are you getting? What answer are you getting for V? 1,1, 2 decimal places. So you're getting cubic decimeters. Yes. Yes. Yeah, it's fine. It's fine. Actually, there's a range for this. If I can just show you here. There's a range because other people will round off, others will won't round off up until the final answer. So your answer, there it is. Your answer must be between 0,568 or 0,57 and 1,62, depending on the rounding off. Your answer must be just between these two. Right. So the first part is the mole ratio, where you find your sulfur dioxide from zinc sulfide, 0,072. Then you use the formula. Number of moles is V over Vm. Then you substitute, right? Then you get your answer. So it's going to be 4 marks. 1 mark for the ratio, 1 mark for the formula, 1 mark for substitution, 1 mark for the answer. So here, the answer for the ratio is being awarded here, but you can also get it here as long as you do that ratio. Clear? Right. Any questions? Any questions? There's option 2 here. On option 2, you can also use approximation, right? To say the mass is to volume. Then you also get that in just 2 simple steps. You can get that particular answer there by using simple proportion. But your ratio, you must just be careful. This is mass is to volume. Mass is to volume. Then it also works out. Yeah? Right. Okay. We move on to 2.2. 2.2. Right, on 2.2, what do we have? Let me just clear this. So the question number 2, 2.1. Yeah. Right, let's look at the first one. Hydrogen, H2, and nitrogen, nitrogen gas, basically. So this is hydrogen gas because there's a G there. And nitrogen gas, there's a G there. Reacts to form ammonia, which is also a gas. The reaction that takes place is represented by the following equation. All right, so you're given N2 plus 3H2 to give you 2NH3. Define the term 1 mole. Define the term 1 mole. What is 1 mole? What is a mole? By definition. Nolutando, what is a mole? What is a mole? Huh? Wait a minute. What is a mole? Wait a minute. A mole. What did you write? Can you read what you wrote there? Definition for a mole. Zama, what is a mole? That's a Google answer. You Googled that one. That's not the, no, that's a wrong definition. You don't use that. Anyone? Apani? Is it Apiwe? It's a Google answer. You use the one in our notes. We don't use that. Anyone? Charlotte? A mole? What is a mole? Same answer from Google. Yes?
Yes, maybe it's an amount of matter which contains as many elements as they are atoms in 12,000 grams of carbon 12.
Right, 12 grams of carbon 12. So it is the amount of substance that contains, it is the amount of substance that contains, it is the amount of substance that contains as many elementary particles, it is the amount of substance that contains as many elementary particles as they are 12 as they are in 12 grams of carbon 12. It is the amount of substance that contains as many elementary particles. It is the amount of substance that contains as many elementary particles as they are in 12 grams of carbon 12. As they are in 12 grams of carbon 12. 12 grams of carbon 12. What is carbon 12? Carbon 12 is it is an isotope of carbon. Yes.
12 grams or 12,000 grams.
No, it's actually supposed to be 12,000. There's a comma. So it's actually 12 grams. So 12,000 is just to 3 decimal places, not 12,000. The 12 grams of carbon 12. 12 grams of carbon 12. Right, so it's the amount of substance that contains as many elementary particles as there are in 12 grams of carbon 12. That's the definition for 1 mole, not the Google definition. Right, next one, 2.1.2. How many moles of ammonia will be produced from 1 mole of hydrogen gas? How many moles of ammonia will be produced from 1 mole of hydrogen gas? What do we say here? What's the answer? What did you get? Yes, Anthony. Yes. Nomtekabo, yes. What's the answer for 2.1.2? 0.67 moles, that's correct. How did you get that? Use the ratio. Ratio from the balanced equation. What is our balanced equation saying? Our balanced equation is up here. No, sorry, I'm going wrong. Okay. Our balanced equation is this one here. All right, so I'm going to check the ratio here. Nitrogen is to hydrogen. So I'm going to do that. Nitrogen is to hydrogen. What is the ratio? The ratio is 1:3. Sorry, no, I'm doing the wrong one. I'm doing the wrong one. Okay, I'm supposed to do hydrogen and ammonia. Right. Right, so I'm supposed to do ammonia, NH3. Which one do I start with? How many moles of ammonia? So my ammonia must be the last. I'm comparing it with hydrogen. So I need hydrogen is to ammonia. What is the ratio? The ratio is 3. 3 is to 1 or 2? 3 is to 2. Right, I'm getting that 3 there and that's 2. So it's 3 is to 2. Now, what if this side I've got a 1 here? How much do I expect to get here? What am I going to do? I'm going to cross multiply. I'm going to say 1 times 2 divided by 3. So my answer is 1 times 2 divided by 3. Right, your answer becomes 0.6666. It recurs. So you round it off to 2 decimal places, which makes it 0.67 moles. Right, any questions so far? So how many moles of ammonia will be produced from 1 mole of hydrogen gas? The answer is 0.67 moles. How do I get that? You use the ratios. You use the ratios. Right, I'm going to stop here for break. Right, let's continue after break at 5 minutes to 12. Right, those at home, it's break time. Let's rejoin, please, at 5 minutes to 12. Thank you.